Alright, so now we're going to move on to question 2. Question 2 states, when a grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at a rate modeled by f of t, where t is measured in pounds per hour and t is the number of hours after the store is opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t, where g of t is measured in pounds per hour and t is the number of hours after the store is opened. So what I started off with doing is just writing out all of the information in an easier to understand way. And now we're going to move on to question A. Question A states, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? So in order to find the actual number of pounds of bananas, you're going to have to use the rate, but you're going to have to integrate the rate. So what I did was I found the integral from 0 to 2 of f of t, and that equals to this expression. And then I plugged it into the calculator, and I got 20.051 pounds of bananas. Question B asks, find the derivative of f when x equals 7. And using correct units, explain the meaning of this in the context of the problem. So what I did, I manually, by hand, found the derivative using the rules of derivatives. What I did was this cancels out since it doesn't have a variable, but for this one, this expression, I broke it into 2, saying that it was 0.8t times sine of t cubed over 100. And so what you do is you do, to find the derivative of u times v, go u times v1 plus times v. So that's exactly what I did. I did 0.8t times cosine of t cubed over 100 times 1 over 100 times 3t squared, which is the derivative of this, using the chain rule. And then I just added 0.8, which is the derivative of that, times sine of t cubed over 100. And I simplified that down to 0.024 t cubed cosine of t cubed over 100 plus 0.8 sine of t cubed over 100. And then I simply just plugged in 7. And when you do that, you get the number negative 8.119 bananas per hour. And this represents that after the store has been open for 7 hours, the rate at which the bananas are being removed from the display table is decreasing by 8.119 bananas per hour. So this is the rate at which the rate is decreasing. Alright, let's move on to C. C says, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. So what I began to think was the rate, to find the actual rate, what I'm going to do is I'm going to find the rate at which the bananas are being added to the rate at which the bananas are being removed, and I'm going to subtract the removal from the addition. If the number is going to be positive, then that means that the rate is actually increasing because you're resulting in more bananas being added than removed. But if it's negative, that means that the rate is going to be decreasing at time t equals 5, because that means that more bananas are going to be removed than added. So what I did was I simply just did g of 5 minus f of 5. And when I plug that into my calculator, I get negative 2.263, which means that it has to be decreasing since it's less than 0. Alright, now for D, it asks how many bananas are on the display table at t equals 8. So first we have to begin by noting that it has 50 pounds of bananas on the display table when the grocery store opens. So 50 is our initial, and then you're going to have to subtract the number of bananas being removed. So as stated before, you have to integrate the rate to find the actual number of bananas that were being removed. So I integrated f of t from the integral 0 to 8, and I subtracted that from 50, but then you have to take into account the number of bananas being added to the grocery stand. But you have, so I added the integral from 3 to 8 of g of t dt. And I did that from 3 to 8 because, again, it does not start until after 3 hours. So the initial minus the taken away plus the added results in 23.3473 pounds of bananas after 8 hours. So that is the end of question 2.